So we have a very basic application up and running right now. It listens on port 4000 on the local host and listens for one root, which you can see right here in main.go/status, and it returns the JSON that we're actually hard coding right now. So it's not doing anything functional, but it is at least working, and it's a good start. But right now we're using the routing functionality that's built right into the standard library. And it works. And right here on line 33, we have a function within a function. In our main func, we have HTTP handle func, which listens for /status and returns the necessary JSON. And that works. And if we really wanted to, we could build our entire application this way. But as you might expect, things will quickly get out of hand. Once we have more than a handful of routes, /status, /whatever it may be, once we get just more than a few of those, this application will become rather unwieldy and really hard to support and maintain. So what we're going to do is we're going to install a router, a third-party package. And I'm going to go to my web browser right now. And the one we're going to install is right here, Julian Schmidt's HTTP router. And it's a very good router, very fast. And it's really well suited for back-end APIs, REST APIs like we're building. Now, the one thing to be aware of, if you scroll down the page here, this paragraph that says only explicit matches. This router only listens for explicit URLs. So you can't have routes that match more than one URL. Now, other routers like the Chi router or the Pat router, they actually will allow you to have pattern matching rules in your routes file. And Julian Schmidt's HTTP router does not. However, since we're not building a web application that builds web pages, we're building a REST API, this is almost perfectly suited for our purposes. So we're going to import this. And I'm going to import it by copying everything in the URL, starting with github.com right until the very end, not the HTTP bit. So I copy that. And I go back to my IDE, and let's install it. So I'll open a terminal window and type go get-u, and then paste in that URL, and hit return. And that will install it. And it modifies our go mod file. And there it is. So it's now available to us. So in order to use this, we're going to make some changes to the way that our application is organized. And the first thing I'm going to do is create a new file, actually a couple of new files. Not in my command folder, but in my command API folder. So I'll right-click and create a new file. I'm going to call this one routes.go. And just so it doesn't throw an error, I'll give it its package declaration. Package main. Now I'll create another one that is specific for our handler, our status handler. I'll create a new file. And I'll call this one statushandler.go. And again, I'll give it just its package declaration for now. Package main. Okay, back in our main file, let's make some changes to the way that we're actually organizing things. So the first thing I want to do is I want to share certain kinds of information between my various handlers in my application. And I could do that with global variables, but that's kind of awkward. So let's take advantage of Go's receivers. And let's create a new type, which I'll create right here on line 20, after line 22. I'll create a new type called application. And this will hold our application configuration. And it's just a struct. And right now, we're only going to put a couple of things in there. We'll put in the config, which we already have. It's of type config, which we defined on line 13. And we'll also put centralized logging in. So a logger is the name of the field, and it's a pointer to the built-in package log.logger from the standard library. Okay? So that's my type. Now, a little bit further down here, in the main function, after line 34 in my code, where I finish parsing my flags, let's create a logger. Logger is assigned the value of, and logger is just a variable name I'm choosing. Again, from the built-in log package, we'll say log.new. And we're going to write, just for now, we'll write to OS standard out. And of course, you can write that to a file. You can do whatever you want with it. But we're going to go with OS standard out. And I hit return, so it should do the import for me. And now specify the log format. We're going to have log ldate right there. And then a pipe and log.ltime. Just so we can know the date and time when we're writing to the log. So that creates our logger file. Now let's create a variable, which I'll just call app because it's our application config. It's a reference to application, the type we just defined. Try that again. Application, the type we just defined, and let's populate its members. So config is obviously the CFG variable, which we defined on line 31, and we populated its two fields with the flags on lines 33 and 34. So that's config. And our logger is just the logger we just created back on line 37. So now I have this application, this variable application, and I'm going to use that as a receiver on my various other parts of my application. So let's go over to our roots file and create a new function in here. And this is where we're going to take advantage of Julian Schmidt's HTTP router. Okay? So I'll create a function, func, and it will have the receiver of app, a pointer to application. And I'm going to call this roots. And this is where we'll put our application roots. And it returns one thing, a pointer to Julian Schmidt's router, HTTP router dot router. Okay? And of course, this type satisfies the necessary interface to be a MUX or a server MUX. So we can use that with no changes to any other parts of our application. So we'll create a new router, which I'll call router. It's assigned the value of HTTP router.new, and that takes new arguments. And we'll create nothing right now. We're going to add our roots in here in a moment, so we'll just return the router. Okay? So that is our first application with one import. And that's all that we need at this point. So let's go back to our main.go and look at how we're going to make this entire thing work. So we have this handler func right now. And what I want to do is create in status handler, I want to duplicate this functionality, but tie it to my application config by creating a handler with a receiver. And I'm going to do that in statushandler.go. So inside of this, let's create a function with the receiver of app, which is of type pointer to application. And we'll call this status handler. And it is a handler, so it requires the same two arguments that every handler in Go does. First of all, I'll name my variable w, and that's an http.response-writer. And it also requires a pointer to an HTTP request, which I'll call r, pointer to http.request. REQ, there we are. And inside of that, I'm going to duplicate the same functionality that I have back in main.go. So I can come into here and just copy all of this. I'll copy it and go back to my statushandler.go and paste it in. Okay. Now there's a couple of changes I have to make. To start with, I can't use cfg.onv. Instead, I'll use my receiver, which is simple enough, app.config.onv. And that's a string, so that's fine. This is a constant at the package level, so I can use that. And now I just need to import my JSON. So I'll just cheat by saying json.marshall indent and hit return, and let it do the imports for me. And again, the last change for our handler is this log. We don't use that one. We use app.logger.println. There. So here, we're using our receiver. And here, we're using our receiver. And this receiver will become very, very useful as we continue building our application. It's just an easy way to share things among the various components of our application in a clean and logical fashion. So I have this handler. Let me go back to my roots file now. And let's actually, where's my roots? There they are. Let's actually do something with this roots file rather than just returning an empty root. So what we'll do is define our only application root that we have right now. And we do it like this. Router, which is the variable we defined on line 7, we give it a handler func, and we need to specify the method. Well, this is going to be a GET request, so we use http.methodGet. Right there. And that's just a constant defined in the standard library. We're going to listen for /status, and we want to go to app.statushandler with no parentheses after it. And that should give us our root. So we're not calling this roots function yet. So let's go back to our main.go and make the last change we need to make. First of all, I can get rid of all of this because we're not using it anymore. I'll change that what's on line 44 to give a more meaningful method shortly. And we don't need that inlined http.handlefunc because we have a roots file. We need to change the way that we're starting our web server. So I'll delete this line. And what I'm going to do is define a new variable right here, which I'll call serve. And that's assigned the value of a reference to from the HTTP package server. And inside of that, we need a few members. The first one is, what do you want to listen to? Our address. Exactly the same as we did before. We're going to listen to localhost, port 4000. So format sprintf, and my string is $d for an integer, and we'll replace that with the value from config.port. The second thing is, what handler do you want to use? And here's what we call our routes, app.routes. The third thing is, how long do you want to time out for an idle connection? So we'll say idle timeout, and we'll make that 1 minute, time.minute, right from the time package in the standard library. And our read timeout, we should give it a sensible value there. If you can't read things within 10 seconds, something's gone wrong. So 10 times time.second. And a write timeout. I'll make that one a little bit longer. Write timeout, our sensible value is 30 seconds. 30 times time.second. So we've created that variable. And now down here, first of all, let's print something out to the log. So we'll use our logger, logger.println. And I'll just print a message that says, starting server on port, and I'll just put cfg.port. And now I'll start the server. Error is assigned the value of serve, the variable we defined on line 46, and we take advantage of one of its built-in methods, listen and serve. And that should be enough to start this application. So first of all, let's make sure there's no errors. Yes, I'm still importing encoding.json or encoding JSON. I don't need that. So I'll just save, and that should clean up my imports. And it did. So no errors here. No errors in routes. And no errors in status handler. So I should be able to start my application now. So because we have multiple Go files in the command/API directory, we can't just say, down here in the terminal, go run cmd/API/main.go. Because we actually have more than one Go file. So on a Mac, you do it like this. Go run cmd/API/star.go. And that will start it up on a Mac. So let's run it just to make sure it runs. And it does. So I'll quit out of it. If you're on Windows, it's a little bit different. You type go run dot for the current directory /cmd/API/dot. And that's how you run it on Windows, assuming you're using the built-in standard Windows terminal. If you're using PowerShell, you probably already know how to do this. I don't, because I don't use PowerShell very often. And if you're using Git Bash, you would run it exactly the same as you do on a Mac. But if you're just using the standard Windows command prompt, you would do it as I show you here. Go run ./cmd/API/dot. But of course I'm on a Mac, so I'll go back to this version. Let's make sure it actually works. So starting server on port 4000, so far so good. Let's go back to our web browser. And let's go back to our standard localhost :4000/status and hit return, and this should work. And it does. Okay, so that works really well. Now, there's a lot of work to do yet, but what we've done so far in this lecture is we've simplified things immensely. So I'm going to hide this and just go through it one more time. First of all, we created a new type, application, and this is where we'll put the information we need to share with our handlers and other components of our application, and that will become incredibly useful as this course goes on. Then we actually down here separated our routes so we don't have to hard code them into our main function. Instead, we're putting them all over, and we can put each handler in its own file or group the handlers into a single file when they're logically related. And we have a routes file that makes our routes ever so easy to manage. All right, that's enough for this time around. Let's move on in the next lecture and start making this application a little more functional.